I want to say a few things about Tesla as related to ICRA 25. We're here at ICRA 25, and uh, one of the biggest takeaways, in my opinion, is the importance of vertical integration. I think this came across as we walked through the expo hall. We spoke to companies like Unitree and Rainbow Robotics out of Korea and many others. There's a lot of interesting companies that have all kinds of different solutions for the stack. What I mean with that is if I look at the robotic stack, I start with the actual metal. So there's a robot. The robot has limbs. The robot has haptic sensors. The robot has cameras. The robot has a battery. And then we go from there towards the operating system of the robot and then all the way up to the application layer. And the vertical integration is absolutely key. One thing that I think we can safely say is that nobody right now has a vertically integrated approach, particularly when it comes to the AI side of things. So a lot of people have the robot and they even have the operating system. I think we gotten to that point, and that's probably a lesson that companies learn from the car industry, that you can't just bend metal. At least you have to have an operating system that helps you navigate the hardware as far as software is concerned. So that's what an operating system does. But I think there is also the AI side of things, and I think that is definitely underappreciated right now. People talk about it, particularly at ICRA. It's clearly there, but I think there is a bit of a fear to maybe, for lack of a better word, fear in terms of there is this traditional side of engineering, let's say call it control theory, model predictive control, a lot of concepts that have been evolved over the last 30, 40 years. And I'm the first to say that all these concepts have value. So it's not like we're just going to throw them out the window. The same way we're not going to throw math out of the window just because our next generation reasoning models will be better at math than humans. Clearly, we're still going to need math to keep training our next gen AI. We need math for reinforcement learning, which in my opinion is the programming language of robotics, or at least the next hot programming language of robotics. So we're going to need a lot of math. We're going to need a lot of model predictive control and a lot of those things. For example, one interesting presentation I saw yesterday was a lady out of, I believe she was out of Notre Dame. I'm not sure. I could be wrong about that. She spoke about distributed model predictive control. So you have a more, maybe a less precise set of variables that define the dynamics of a system, and then you can learn those variables, right? So you can have a system of linear equations with variables that aren't fixed, that can be learned. So we can use the engineering side and just replace the variables that the engineers used to use and fix with learned variables. So that's one approach where we think learning and traditional engineering come across. But that's not the point of this episode. What I want to talk about this episode is really the importance of vertical integration. I also want to talk about you get what you compensate for, which is in terms of Tesla shareholders, we have to be very clear for who's running our company and what are we in for. And that means that we're going to have to invest a lot in AI. Elon Musk is doubling down, tripling down, quadrupling down on AI because he sees that as the absolute holy grail. So a lot of compute time, and Jensen's law will drive us towards much, much faster adoption of intelligence. We're going to have foundation models for robots. We're going to have the ability to learn from video. That's very important. That's another thing that it dawned to me now as I just think about what has been said in the last couple of weeks, maybe last couple of days, actually. For example, the data scarcity in robotics, right? How do you solve data scarcity in robotics? Well, you can learn from video. We have teleoperation. already, but if we could internet scale video, apply internet scale video to robot learning, this would be a big breakthrough. I think Musk actually spoke about this on the Faber interview with CNBC just 2 days ago, and he spoke about that. So I think this is very, very important. It hasn't been discussed explicitly at ICRA, but I think what this means is that we're going to have enormous amount of data from people, let's say, to do videos, which are abundant on YouTube. The problem with robotics is that we have a video, but we don't have the connection between the visuals and the actuators. Now, Tesla has done this for FSD in China, so it looks like there is transfer learning there. The problem from a technical perspective is that you have a vision. So let's say, I don't know, you watch a barista making coffee with a coffee machine, espresso, right? You can see how that's done, and as a human, you probably have a good sense for how to do it. The robot has to learn everything from scratch. But if you have a teleoperator that maybe kicks it off with a bunch of priors, well, then maybe you can actually learn from video. And if you transfer the video, the third-person view onto first-person view, which is the attribute that the robot has, which is a kind of a transition function that is probably learnable, you could do it. So it looks like there is a lot of opportunity there, and of course that requires a lot of data. And we're back to the million GPUs. We're back to the gigawatt or terawatt hour level. I lost track of the numbers, but it looks like Musk is really doubling down. He wants to put AI into the realm of large-scale infrastructure investment. That's what he's really interested in. And I think that's something that ICRA hasn't maybe discussed. That hasn't been discussed as explicitly at ICRA. The fact that, I mean, actually it has been discussed. I already mentioned it, but it's been sort of on the side. There was a gentleman from University of Michigan who spoke about this. So it's the bitter lesson concept. So the bitter lesson concept, which is, look, a lot of data, general models, a lot of data, general models. So those are the kinds of things I want to talk about here. It's a lot, but it's really only one theme, and that is vertical integration. Because to make all this work, you need to be vertically integrated. Why is that important? Because you can look at the robot as a stack. It starts with the metal, and it goes all the way to the GPU cluster, which is training the AI. It is all one stack because we have the embodiment, which is very important for robotics. So we can't just generalize an AI stack for robots without having a sense for the embodiment. And what that means is not just, okay, it has 5 fingers, but I need to understand how many degrees of freedom. I need to understand how these interact with each other. So do the haptics actually talk to the limb actuators the same way we humans actually work? Or is it, all these things matter. And it's going to be very, very difficult for companies, whether it's Unitree, whether it's Rainbow Robotics, or anybody out there, Figure, and so on and so forth, to do this without full vertical integration. Now, I'm not saying Tesla is the only company which is doing full vertical integration. Clearly, I think Figure is doing it. Others are doing it. There is enough room for people. China, I'm sure, has figured that out also, companies there and entrepreneurs. The point, though, is that we have a CEO here in Elon Musk who is willing to bet a lot of money, and he has the money. He has the money on his balance sheet. Tesla has over $35 billion in cash, but he also has the will and the power and the risk-taking capacity and the culture in the company which can do this. So this is very, very crucial. And I just want to double down on this. Like, why is vertical integration so important? Well, the easy answer is just look at Apple. Or even like companies like Disney or Ford back in the day, right? I mean, the reason they succeeded, why am I using Disney? I find like, Walt Disney, the early, not today's company, that's a very different story, excuse me. But back in the day, Walt Disney, the Disney company was an innovator in animation and entertainment. And because they were fully integrated, they were able to go from drawing cartoons all the way to creating what today's ABC network and all of these things. because they were fully integrated, it was actually a success because they understood entertainment, they understood the production, they understood the distribution. So just as a side note. But anyway, I think the big, look at Amazon, fully integrated, full stack from the website all the way to your house, delivered. Same with AWS on the software side, pioneering cloud computing. You've got to be vertically integrated to make big things work and really change industries. Now, technically, what it means is that if you look at the stack all the way from the AI down to the robot, again, the embodiment is important. So you can train your GPU cluster already anticipating the kinds of commands that you're going to have to optimize for when you put it on the robot. So therefore, you gotta be able to come from both sides. You gotta be able to come from the engineering side and talk to the AI people, and the AI people have talked to the engineers. And of course, the other side of the coin, which is the most important one, is always, and I think for regular listeners, you will know, we define a company by its cost structure. And the success in humanoid robots, or let's call it generalized robot. They don't have to be humanoid necessarily. It can be smaller, taller, it can have 6 fingers. It doesn't really matter that much. But generalized robots that can solve problems, whether it's gas leak detection, nuclear power, accident stuff, fire police stuff, or even if you want to go there, home appliance, kitchen cleaning, all that stuff. If you want to have a generalized robot, the same way, let's say we had a generalized PC, if you want to have something like that, you got to have it at low cost. And this is where Tesla, again, is absolutely key. We said it also with the car. It's going to be design, it's going to be AI, but in the end, it's going to be Lars, who is the head of engineering and manufacturing, and the same applies to Optimus. It's going to be the people who actually can build this at scale, who can actually bend the metal at scale at a low cost. If we can bring this down to $20,000, $25,000, then that will win. It's going to be the cost, and it's always going to be dollar per something. Either it's going to be dollar per hour worked, or dollar per solution, or something like that, and we want to minimize that. So again, vertical integration is absolutely key. I want to talk a little bit about this concept also of the bitter lesson. I spoke about this already in my first ICRA comment. So to bitter lesson or not to bitter lesson, what does that actually mean? Okay, like, look, most of ICRA is about bespoke approaches to engineering problems. Some of them are autonomous, most of them are actually not even autonomous, but there's a lot of interesting ideas. We can improve multiple control. We can improve. We can use bio-inspired ideas for better design of drones. There's a lot of different types of approaches, but the key to intelligence and the key to a generalized robot which can solve problems through AI, and I'm going to define that in a second. The key is going to be the bitter lesson. Now, what do I mean with AI? So if I take 2 robots, one robot which is, let's say, the KUKA robot or the Fanuc robot, those are robots which are predefined, determined to do a very specific task, and they're very good at it, very fast. We have very high precision and all of that stuff. The generalized robot needs to be able to act based on input and have a generalized, flexible reaction function. And that's the reaction function is actually what we're learning. That's what we're calling it AI these days. It's certainly more than just machine learning, but it's learned. And whether it's learned through reinforcement learning, whether it's learned through machine learning, that's for another episode. The point is, though, that we can learn a reaction function based on input and then solve problems. Let's say if the robot sees that the room is dirty, it cleans the room. If the robot sees that there's a screw to be unscrewed, or if it's told, if the input is, hey, go unscrew the screw, it goes unscrews the screw, maybe in a very difficult spot to reach, dangerous for humans, that kind of thing, or a rooftop robot or whatever, stuff like that. Roofer robot. So it needs to react based on inputs, and that's what AI is. So in order to achieve that type of intelligence, we need to go with the bitter lesson. This is key. And the last thing I want to mention today, it's another tidbit from Musk's comments that he gave. I think it was the CNBC interview, or maybe it was at Qatar, at that not so good interview that this biased Bloomberg reporter gave. But he spoke about energy, okay? And I'll just spend a few words on that too, okay? So energy is a national security issue. Always has been, always will be. But it's becoming even more important now because energy and AI are tightly related. If we want to go to terawatt hour type, or maybe not terawatt, but definitely gigawatt hour level of AI training clusters, which is what Musk has been talking about, we need energy. We need energy in all kinds of forms, and we need energy at the right place, at the right time, at the right quality. That's very important. Now, maybe the frequency control that data centers need could be a little bit overstated also by the electricity industry. I am not familiar with that because I could think that maybe software can solve some of those problems. Drew Balino is starting a new company to do transformers because there is a shortage of electrical equipment right now. So we have enough electricity for now, but we don't have enough transformers, so equipment which can transform high voltage into the right voltage and the right stability of voltage that is necessary for data centers. But of course, if we go to gigawatt hour type training, and we're not just going to be doing this in one company, we're going to be doing this in a few, and at some point in all of them. I think the bitter lesson will win, there's no question about it. And if the bitter lesson wins in robotics, in real world AI, then we have this trifecta of AI training, traditional sort of GPT, Grok type of way. We have reinforcement learning and this concept of generating synthetic data. And then third, we also have this embodiment explosion. So we have the need to physically simulate intelligence or potential robots to even understand what kind of embodiments we should have. So we need physics simulators, we need reinforcement learning for the actual intelligence, and then we need the general purpose sort of intelligence, if you will, like ChatGPT. So there's a lot of necessity for training data, a lot of necessity for data management. And when I say a lot, maybe that's not the right word. It's gigantic. It's a lot more than we understand now because we're going to create lots of synthetic data. What do I mean with that? If you do reinforcement learning, let's say a robot learns how to thread a needle. Like it's gonna, let's say, have 10 million trials until it actually learns how to thread a needle. The 9,999,999 trials that were not successful, all of them are data, because what we've learned is that all the mistakes, if we all combine them into a big model for other tasks, whether it's cleaning dishes, this data from threading the needle can be very useful. That is absolutely key. That is, I can't emphasize enough. I mean, I'm not the only one. Sergey Levin is a big proponent. All the Google RTX and RT2 teams have spoken about this. I think most AI researchers, at least on the West Coast, where I'm situated, Dieter Fox at Paul Allen, he talks about this. I mean, this is definitely happening. So, to summarize, vertical integration is going to win in the robotics race. We have a CEO who's willing to bet on the bitter lesson. We need to compensate him. What we compensate for, that's what we're going to get. So if we compensate Musk appropriately for the risks he's taking, we're also going to win. We're going to 10x the stock. And energy is a national security issue because energy and AI are tightly related. In fact, energy and AI are going to become the same concept, a little bit like transportation. I mean, you don't have transportation without energy. And the same way, you're not going to have intelligence, artificial intelligence, or just generally, let's not even use the word artificial anymore, just intelligence in general, is going to be a function of energy. Thanks.